given function fx is a piecewise function and gx also a piecewise function are continuous at x equals to 2. So when we're having a piecewise function, it will be easier for us to observe the function by drawing out its interval. So for function fx, when you have more than 2 is a quadratic. When you're having less than 2 is a linear. Meanwhile, for function gx, when you're more than equal to, it will be a linear 4 minus 2x, less than 2, b minus x. So since they are continuous at x equals to 2, so means that at this changing point, the function changing at this point, they are continuous. So by using the continuity condition, so limit when x approaches 2 from the left hand side, x minus 2 supposed to be equal limit approaches 2 from the right hand side. So this only show limit is exists. So for continuity, we have the third condition saying it will be equals to the point. So F2 will be at the point of quadratic. So it's supposed to be equals to F2. Then we evaluate this limit, substitute 2, we get 0. Therefore, we can get 2a equals to negative 12, a equals to negative 6. Then for function g, to make sure it is continuous at x equals to 2, with the continuity condition also, we doing limit from the left hand side equals to the limit from the right hand side. And it must equals to the point of the g2. So g2 is 4 at the 4 minus 2x, which is at the right hand side here. So here will be equals to g2 function g, the point of 2 at function g. Then we substitute. So b will be equals to 2. Then after that, we need to show up when the function g minus function f also a continuous at x equals to 2. So first of all, we figure out what is the function g minus f. So which is gx minus fx. So both of them also have a changing point at x equals to 2. So we do it in piecewise. For the x more than 2, the right hand side, it will be gx, which is 4 minus 2x, minus fx quadratic, which is x squared plus a plus 8, where this is the interval which is more than equal to. So for the interval less than equals to, it will be minus x, which is 2 minus x, minus fx, x minus 2, x less than 2. So we form up this piecewise, simplify it, we're getting negative x squared, so this one negative 2x plus 6x, having positive 4x. The constant 4 minus 8, negative 4. And then x minus x, negative 2x, 2 plus 2 will be 4. So after we identify this function g minus f, we show out it is continuous at x equals to 2. So by the continuity condition, we need to show that g minus f at the point of 2. We have to show it is defined. So when you equals to 2, you'll be 4 on this quadratic function. We need to calculate out. So we get 0 means that this point is defined. We can see the coordinate means the point is defined. Then number 2, we have to identify the limit exists or not. So limit approaches 2 from the left hand side of this function will be negative 2x plus 4. Calculate this limit separately because we want to identify whether it is continuous or not, the limit exists or not, so we need to calculate separately. Look on the result, substitute 2, we also getting 0. So for this part, when we substitute 2, also 0 means limit when x approaches the 2 for the function g minus f x equals to 0. So it is exists because their left hand side of the function equals to right hand side of the function. Then condition number 3. It will be determine whether the point and the limit equals or not. So we can notice that since limit when x approaches 2 for this function is equals to the coordinate of the 2, which is the value of 0. Therefore, we can conclude that g minus fx function is continuous at x equals to 2.